This is a tutorial to teach you about t-tests. Now, t-tests are a way to compare mean differences. There are a few different types of t-tests, but the most common is when you compare two groups on a given variable. So, for example, I would run a t-test if I wanted to see if men or women go to church more often, or whether kids or teens eat more peanut butter and jelly sandwiches. An important thing that we need to talk about with t-tests is hypothesis testing. So a hypothesis test, you have a null hypothesis, which means there is no difference between the groups, and an alternative hypothesis, which means there is a difference between the groups. When we have a significance, so a significant mean difference means that we got a p less than 0.05, and that means there is a significant difference between the groups, so we reject the whole null hypothesis and accept the alternative hypothesis and conclude there is a difference between the groups. This is kind of complicated, but it is important for t-tests. So what does our data need to look like? You need two variables, one that is categorical, such as gender, male or female, religious affiliation, any other grouping variable, and another one that's your dependent variable, and that's going to be continuous. So for example, what year did you get married? Before 1980, 1980s. This is a continuous variable because 6 being 2016 to 2018 is higher than 1 being before 1980. So the numbers actually mean something, whereas with this, the numbers don't really mean anything. I could have put female as a 1 and male as a 2, and it would have done the exact same thing. This one is also a continuous variable because the numbers mean something. We've got a 1 between 0 and 3 months and 7 more than 2 years. So if the numbers, so we need one thing that's categorical and one thing that's continuous. All right, now let's actually go through a question. Here is my question. I want to know whether men and women differ on the number of committed relationships they had before dating their spouse. So this is number of committed relationships they had before dating their spouse, Q10, and we want to compare it with gender. And we've got my males as 1 and my females as 2. Let's run frequencies really fast on my data. So I'm just going to push reset there. That's gender and control click to get both of them. I'll just click OK, that's fine. So my sample is skewed, but that could be because females answer more Facebook surveys than males do. And how many committed relationships did you have? It looks pretty good. So I probably wouldn't use this data for my thesis, but it's good enough for this video. So what I want to do is analyze compare means independent samples t-test. All right, your test variable is your dependent variable, and I want how many committed relationships did you have? What is your gender? That's my grouping variable, and now I need to define the groups. I want males and females. And remember, we looked at the data before and saw that males were 1 and females were 2. So look at your data, find out which 2 you want, and then define it. We'll paste it because I might want to run this multiple times. So then I come here, and it, again, SPSS created the command for you, which is really great. I want to run that, and now we get our output. So in this output, we have how many committed relationships did you have before your spouse? We have 17 men, and their mean is 2.59. We have 87 women, and their mean is 2.45. And now in this independent samples test, we have 2 bits of information that we have to look at. This first part, just this box right here, Levine's test for equality of variances, is going to determine which line we use. So if we go back here, we have a null hypothesis, there is no difference, alternative hypothesis, there is a difference, and p less than 0.05 means there is a significant difference. So we want equality of variances. So this is significant because the P is, here's our significance right there, SIG, significance. It's less than 0.05, so that means there is a difference between the groups, so equal variance is not assumed because our groups are not equal. So then we look at this bottom line and we report this T statistic. The degrees of freedom is usually pretty useful too. And then this significance tells us whether I have mean differences or whether I don't. So this 0.739 is greater than 0.05, meaning there are no significant differences between men and women on the number of committed relationships they had before they started dating their spouse. So if I was writing up a results section, I'd say something like, a t-test was conducted to determine if men and women differ on the number of committed relationships a participant had before starting to date their spouse. A Levine's test was run to test equality of variances between the two distributions, and the assumption was violated. We've got this F statistic and our p-value, meaning that equal variances cannot be assumed. The results of the t-test suggest that there is not a significant difference with my t and a p-value between men. Mean equals 2.59 and women 2.45 in the number of committed relationships an individual has before starting to date their spouse. And we've got this table here. I just threw this together really fast, so use this as a model, but this is not a perfect APA results section. I just threw it together really fast. And that's a t-test. The last thing I wanted to do was show you exactly what you can do with groups. So this was easy because gender was already in groups. But what if I wanted to figure out, I wanted to group these individuals differently. Let's say I wanted to group everyone that got married before 2010 and everyone that got married after 2010. Well, that's where I would use this transform, recode into different variable, click reset again. I'd come here and grab what year did you get married. I would name it something like marriage group. I would say before 2010 is a 0, just to remind myself, and after 2010 is a 1. And that's just telling me, when I look at the data later, it's telling me what I coded it as, because that helps me know. So then I go old and new values, and I remember that we are going to do a range here. We could go 1 through 4. It's going to be a 0. And I'm going to do 5 through 6. It's going to be a 1. I also could have done range lowest through 4 is going to be a 0. Range 5 through highest is going to be a 1. I could have done any of those things, or I could have just done discrete values. 1, I could have done 1 goes to 0, and then 2 goes to 0, and 3 goes to 0, and 4 goes to 0. I find that and then if you wanted to do all other values into something, you could. And it's just a really useful tool, because then when you continue and you move that over, you click paste and you come here, then you can run it, and it creates this new group over here, which when you come this way, come all the way to the end, it tells you whether they belong in the 0 or the 1 group. So you can create a group and then run a t-test based on that group. If you have any more questions, come talk to me. I would be happy to help any of your help answer any of the questions that you may have.